What's up, guys? Team 8 here, back with our Battle Frog Rube Goldberg presentation. This is our second stage of the project. I'm Jack Strolla.
I'm Joel Owen.
I'm Jun Yoon. So this is Team 8's revised schedule. There is not much difference from our schedule from the previous report, except that our intellectual properties research happened later in the project than we thought. But this is not going to have an impact on our finish date because it is not a task on the critical path. And this is our design structure matrix. From here, you can see that concept testing is our most important task. This was because we wanted to make sure that our BRG project actually functions and completes through the end. So many tasks such as the product architecture and some of the design processes require many iterations of testing to actually complete. And this is our intellectual properties research. These are some of the patents that we got ideas from for our stations. We used the first patent for station 1, the next two for station 3, and then the next two for station 2. So for station 1, we got the idea to use a magnet to lift an object a certain height. And for station 3, we got the idea to create a handheld maze that can be controlled manually to guide a ball through a course. And station 2, we got the idea to create sort of like a Plinko machine. And none of these ideas had any legal repercussions because many of the patents had expired already, and the other patents that had not expired yet, we didn't use any ideas from them.
For each station, there were 3 ideas that were generated. The first station, gravitation, had an Arduino-powered fan that would raise a ping pong ball up and down. Magnetic force, where the user would use a magnet to guide a metal ball triggered by the ping pong ball through the course. And then the third and final idea for station 1 was projectile motion, where we would use a catapult to launch it onto the next part of the track. The team has decided to pursue magnetic force because it had the most repeatability by the user. And then so as the metal ball rolls down, the user will actually guide it with the magnet. And then if the user pulls too far away, then gravity will win and it will drop the ball and roll back to the starting location. We were finding issues, especially with projectile motion, being able to get that repeatability. And this station also offered an additional teaching concept with magnets that we thought was an added bonus to the teachers being able to teach first graders about magnets. For station 2, we were looking at addition. The first idea for this was using Wheel of Fortune, and the second was a pegboard, and then the third and final was a random number generator. Each idea generated different numbers where the user would then need to add them together, and then the teacher would be able to enter them into the Arduino, and upon getting the correct answer, a gate would open and then the ping pong ball would continue through. And the first station would get those numbers by the ping pong ball rolling through and spinning around the wheel. The second one would be activated where a lever would pop up, releasing ping pong ball through the pegboard. And then the third one the ping pong ball would roll through, and then as it passed different signals, that would be able to alert the Arduino to generate different numbers for the user to, again, input. The team has decided to pursue the pegboard. This really connected well with our first station. The magnetic ball, as it reached the top of that station, would drop into a 3D part that we'll explain later, and that will raise a lever, releasing those ping pong balls. And then we just really liked how easy that went with station 1. In addition, it also added a lot of excitement and was aesthetically pleasing to the user, which was great for first graders. It really kept them engaged, and we'll get them excited about this station. For station 3, we were teaching motion, and the 3 ideas was a maze, a ramp, and then a slide. And the first idea, the user would be able to pick it up and guide the ball through the maze. The second idea, the ball would be rolling in after station 2 and trace the different types of motion needed to end the ramp. And then the third idea was the user would blow through a straw and it would raise the ball up, and looking at different motion. It was going up and then like bending around a ramp as well. And the team has actually decided to combine 2 of these ideas, both the maze and the slide. And the purpose of this is to just add more motion and be able to better teach the concept of different movements and different angles and direction. And then it also will allow the ping pong ball to reach the desired maximum speed or the desired exit speed for the BRG.
So we also had to perform a failure modes and effects analysis on these stations that we built. The only imminent danger of the station is in station 1, there's that magnetic ball that you're using to go up the ramp. This could pose a slight issue if someone has a pacemaker, because it might have some sort of magnetic interaction with the pacemaker and maybe make it beat off beat. This shouldn't be a huge issue, however, though. It would be super rare because most people don't have pacemakers, and most pacemakers are designed with having some sort of magnetic field in place that counters anything that might interrupt it. Another issue is that the Plinko station, which is pretty tall and pretty heavy because it'll be made out of wood, if it's not set up properly, it might fall over, and if someone's hand or fingers are under there, they could potentially get crushed underneath it if it's falling. But this won't happen if the board is properly set up, so there will be explicit instructions provided with the kit that'll say to make sure the pegs on the bottom are plugged into the pegboard and it won't be able to slide. The last thing that could happen with any of the stations or connections is that the ping pong ball might fall off the track, but we've tried to design most of the stations with this in mind and make the walls high enough that even under extreme circumstances, the ball won't be able to fall off.
For one of the parts of the BRG, we needed to make a part using a 3D printer and manufacture this. And so to do the best analysis, we did several different orientations and just observed using a MATLAB code the different effects on the amount of material used and support material, as well as the length of time and the cost for this part. And we've decided to integrate this for station 2, where the lever part of the pegboard would collect the metal ball, and then it would lift up and then release ping pong balls through the pegboard. And so it's a pretty simple design. However, the dimensions were really small, being about 2 inches. And so finding either a metal or a wooden box that was durable enough was hard to find, and then it was pretty incapable to be able to make a lot of these efficiently. And so that's the reason why we decided to pursue this part and make it using the 3-dimensional printer. And then with the MATLAB code, we were able to find that it will take about an hour and a half to make, and just shy of $18. And it's going to use about 100,000 millimeters cubed of material with a little bit of support material underneath as well.
So our economics for the project is that we would like to request a $15,000 initial investment from VTEPS. This would be used to pay for the tools and materials that we would need to mass produce our BRG. We would pay this back over the course of 4 years at an annual interest rate of 15%, which comes out to 3.75% quarterly. Based on the economic analysis that we did in our first report, we found that our project could make $5,500 per quarter, which is $22,000 annually in pure revenue. So if we're paying off it a $15,000 loan at 3.75% quarterly, that comes out to almost $2,800 that we'd be paying back to VTEPS per quarter. And if you subtract that from the $5,500 of revenue that we'll be getting, you'll get somewhere around $2,700 of profit per quarter for our team. Over the course of 4 years, this results in VTEPS making $33,200, which is a big step up from their $15,000 investment, making it a worthwhile investment for them. And we'd end up getting just shy of $33,000 as well, so it's profitable for both companies. So in conclusion, our team is on schedule to complete this project by April 28th. Research on patents has been completed, so we're not infringing on anything, and we've done plenty of models and prototypes for each station, so we know how the stations are going to work, what the final is going to look like. We're just working on actually building the final project now. All these stations have been analyzed for potential dangers and failure modes, and we've tried to equip the stations so that these don't happen. And finally, the project is mutually beneficial for both VTEPS and Battlefrog, so both companies will make money, and it's a worthwhile investment of both of our time.